Hello and welcome to the channel Understanding.Concepts.Of.Physics. Today we are here to derive the equation of a stationary wave on a string. As you can see on the screen, we have written the topic name as well as the diagram associated with it. So let's just quickly start onto this video and let's see how the derivation works. So initially, as you start with the equation of stationary wave, you are supposed to write the definitions for stationary wave, and which says that when two progressive waves traveling in the medium along the same path but in the opposite direction superimpose, then the resultant wave, which is obtained in the form of loops, is called as stationary waves. So this is definition I have explained to you in one of the previous videos. If you can see, I have my coordinate system x-axis and y-axis over here. I have just not mentioned it, I'll just mention it. This is my x-axis and this is my y-axis. And there is this magenta color wave which is traveling in the positive direction of x, and there is this rigid boundary which is fixed it over here. So this is not moving, this and we know that when a draw hits a rigid boundary, it is going to come back as a crest. So now it is going to come back as a crest. So this greenish color wave is basically coming back. I have shown you the arrows where it is going to travel. And the points of the medium which vibrate with negligible amplitude or zero amplitude are called as nodes, and these are called as antinodes, which are vibrating with the maximum amplitude. So this point is maximum amplitude, this point is a maximum amplitude, and so on and so forth. So these are what's called as nodes and antinodes. So diagram is such and so forth. Then in one of my previous videos we have also discussed about how to what is the equation of a progressive wave. So a wave which is traveling in the positive direction of x is given by this equation. Note the minus sign. And when a wave is traveling in the positive direction of x, oh, I just made a mistake, there should be a negative sign over here. So negative direction of x. Okay, so when a wave is traveling in the negative direction of x, there should be a plus over it. So the only difference is minus and a plus. So if you want to know what link is it, then previous videos are really going to help you. Search it from the playlist. So these are the two equations of progressive waves which is traveling in the positive direction as in the negative direction. And now what we are going to do is, because they are superimposing, I am going to apply the principle of superposition. Now very quickly you should be knowing what principle of superposition is. Principle of superposition is like, okay, if a wave is traveling, or if any vector, if you are adding a vector to a vector, you should add them vectorally. Okay, and vectorally means in vectors it is not like 2 plus 3 is not always equal to 5. Okay, it also depends upon on what angle it is coming. So right now we are not assuming that the waves are coming at a different angles. We are assuming that both the waves are traveling along the same path. So this resultant displacement is equal to displacement due to the first and the displacement due to the second. Now, because vectors are, when they are in a line, you can just add them algebraically. So I have written y is equal to y1 plus y2. Now somebody might question, okay, if one wave is traveling in the positive direction and then another is traveling in the negative direction, then why am I not using a minus sign over here? Now I could have used a minus sign, but then again this minus sign and this plus sign is actually giving you the information that one wave is traveling in the positive direction and one is traveling in the negative direction. So now there is a purpose for writing y2 plus y1, and I would just switch this over y1 and y2 here, and y2 plus y1 I have written. I have put the value of y2 over here and I have put the value of y1 over here. So I just pulled in those values y1 and y2 and substituted over here. Okay, so y2 is somewhere here, y1 is somewhere around here. Okay, now when I see this, there is an a over here, there is an a over here, a is getting common, so I just missed out one bracket, so I'll put a bracket, square bracket. Okay, so this a is basically common, which is thrown outside, and this is like sine a is not there, and this is entire thing. This is sine a, this angle is treated as a, and this angle is treated as b. This is sine a plus sine b. Now we have a formula for sine a plus sine b in our math, which looks something like this. sine A plus sine, it's not sine A plus B, sine, this is sine A plus sine B. Okay, so sine A plus sine B is equal to 2 sine A plus B by 2 into cos of A minus B by 2. Now these formulas are called, in math it is called as factorizations formula, or there are total 4, there are 4 formulas, and then there is defactorization formula, and these are also 4. Okay, so there are total 8 formulas. So I'll just give you a link how to remember this all 8 formulas, and this will be very helpful in your physics as well. As of now, I just would like to complete the derivation. So just remember, sine A plus sine B is equal to 2 sine A plus B into upon 2 into cos of A minus B upon 2. So in this case, this is my A and this is my B. So first of all, 2 is outside, sine A plus B upon 2. So the upon 2 you can see over here. Okay, if you could see this formula, the upon 2 is present over here. But now A plus B, now A plus B means this should be added with this. So I'm seeing that 2 pi is common, so I've taken 2 pi common. Nt plus x by lambda, that is nt plus x by lambda, plus nt minus x by lambda, so nt minus x by lambda, and upon 2 is as it is. Okay, so just have a look at it, try to figure it out using this formula, and you will be through. So it's just basically the application of this formula. Then you have an into, like how you have a multiplication in the formula, and then you have a cos, and you have a minus b upon 2. Okay, so cos a minus b upon 2 means, that means if this is my a and this is my b, then a minus b I'll have to do it. So I'm seeing that in this a and in this b, 2 pi is a common thing, so I've taken 2 pi common outside. Nt plus x by lambda is as it is, this is nt plus x by lambda, and then you have to subtract this, so that is minus nt, and minus into minus will become plus, that is why x by lambda. Okay, so just subtracting this and this, so I'll get this, and upon 2 is as it is. So this is what I have applied the factorization formula. Now I'll come back to this, the logic behind all remembering all these formulas for factorization and defactorization. Let's see. Now okay, so now what we are going to do is this, because there is a multiplication here, there is a multiplication here, there is no point in putting this bracket, so I have removed that bracket. 2 into a is nothing but 2a. Sign is as it is. Okay, now plus x by lambda and minus x by lambda gets cancelled, and I get nt plus nt, I'll get 2nt, and this 2 and this 2 will also get cancelled. What remains is only nt and this 2 pi, so I have 2 pi nt into cos of. Now here also, like plus nt and minus nt will get cancelled out, and I get x by lambda plus 2x plus x by lambda, that is 2x by lambda, 2x by lambda. Now this 2 and this 2 will get cancelled out, and I'll remain with x by lambda and 2 pi only, so 2 pi x by lambda. So out of the entire derivation, I have just come to an equation in which we are getting a very small equation. Now here we are going to assume that this 2a and this cos of 2 pi x by lambda, okay, this 2a and this cos of 2 pi x by lambda, and we are going to assume it as a. So if when we are assuming this as a, I'll just replace it, and this 2a cancelled off, cos of 2 pi x by lambda cancelled off, and in place of that I get a, so that's a, and sine of 2 pi nt remains as it is, so sine of 2 pi nt. Lastly, note that your a is depending on x, it varies with position. X is position and a is amplitude, resultant amplitude, and your displacement, that is y, your displacement is varying with respect to time. So that's the reason, because this amplitude is not varying with time, you are seeing that the amplitude actually, the wave is actually stationary with respect to the time. Also, now I just mentioned why I have taken this y2 plus y1 and not y1 plus y2, and the reason is, when you apply this factorization and defactorization formula, there is a condition which is saying that angle A should be greater than angle B, A should be greater than B, and then you should apply this formula. Okay, this is a condition in math. So if I had taken y1 and plus y2 and I had applied that formula for factorization, then this would have been minus and this would have been plus, which would have made this angle smaller and this angle bigger, B angle bigger and A angle smaller. then that formula would not have been applicable. So in order to apply that formula, angle A should be greater than angle B. That's the reason why I have written it other way, y2 plus y1, and I have solved it. Now I have done this entire derivation with the maximum number of steps, but just in case if you are familiar with math and maths is not a problem for you, then you can definitely cut down on few steps and recreate your own derivation. Okay, so that's one thing. Also, I promised you about making a trick to learn all the formulas for factorization and defactorization formula. So if you wish to learn those formulas, you just have to remember SC, CS, CC, SS. Okay, so you just have to remember this SC, CS, CC, SS in an order. Then what you do is you apply 2 to each term. So I have just written 2 to each term, and then I would write equal to each term. Then remember that your first trigonometric function is sine, and your first operation means plus, minus, multiplication, division, these are operations. Your first operation is plus, so the first equation is s plus s, then you have s minus s, then you have cos plus cos, and then you have cos minus cos. So if you just remember this part, if you just remember this much of what I have written, like you're supposed to just remember SC, CS, and CC, SC, CS, CC, SS. If you remember that, you can just develop this logic. Now if you just read it from this side to this side, this is factorization formula, and if you read from this side to this side, it's defactorization formula. Okay, so I'm not giving you the whole thing, but I am giving you food for thought. Okay, how to develop all the rest of the formulas, all the 7 of the formulas, by seeing this. So one of the formulas is done for you. If you see sine A, this is sine A plus sine B is equal to 2 sine A plus B by 2 into cos A minus B by 2. Okay, so try to figure out for this as well. These things remain same, you just have to manipulate a certain things, write it on a note, and then check on to some authentic sources from some math notebook or somewhere where you can actually test this will actually work with a slight variation in the 4th formula. So I hope you might have understood what I am trying to say, and connect with me in the future videos as well. Subscribe the channel and keep following. Ask your friends and families to subscribe as well. Thank you so much. Have a nice day. Bye.